Plug it, huh? So first thing you're doing is this is the main board, and the board is just being soldered. So this should be in normal connection. You're testing the board without your MOSFET board. So this is negative and this is positive, as you can see very well. So I connected the negative to the negative side of the board and the positive to the input, the same connection to your MOSFET. So after done that, what you're going to do is this. If you check the LCD very well, starting for the first pin, you see your VSS, that's a negative, the positive, your constant, your register pin, your read and write, your enable pin, and your data pin. And also with your A and K, that's your anode and the cathode for the backlight of the LCD. So same thing is being applicable to the board. So you have your VSS, your VE, your VCC, your VO. So the same connection from a VSS to your E. Same thing is here, VSS to E. That is to say, the first line of the LCD flex, I splitted it. The first line of the LCD flex, that's your VSS. Now your VSS is right here, and your VE is here. So you have to just position it in such a manner that it's going to connect together. So that's it. VSS to VSS, VE, and E to E on the board. So from your D4 to your K. Now this is D4 on the LCD and K. So what you're going to do is this. You pick it from a D4. You connect to D4, this is D4 right here, and this is the K. So you connect it just like this. So it's all done. So what else you need to consider again is this. Without the temperature sensor being connected to it, this board is not going to work. It's not going to work at all. So this is the indicator and this is the relay. As I said earlier on, for a 12 volt inverter, use a 12 volt relay. A 24 volt, use a 24 volt relay. A 48 volts, use a 24 volt relay. Now,
what of 96?
Use an external relay for that one. So what you need to do again, apart from that, put into consideration, you attach your current sensor. Your current sensor is one doing the body overload, the charging amperage and everything. So one more thing for you to notice again is this. This is for the keypad connection. So this is my pin 1 of my keypad. I'm a pin 4 of my keypad. This is my main inverter on and off, as in not the main, the one for the on and off of the oscillation. Now this is the main. When I say main, that's your master switch. Do not shut down the board permanently. So this is the MOSFET extension board. That's where you connect your MOSFET to it. So now one more thing you have to put into consideration is this. On the board, there's a point that is being written greater than 24 volts input. So now, one thing you have to know is this point that is being written greater than 24 volts input, there's a jumper there. So if you're using a voltage less than 36 volts, that is to say, using a 24 volts power supply or 24 volt battery or a 12 volts, you can use the board directly without external regulator. But any voltage above 24, probably it is only 36 volts inverter up to 96 volts, you have to connect your 12 volts input to the upper side of the jumper and your 48 volts or any other voltage to the lower side of the jumper. That's all for that. So I think we're done. It's just going through the, and meanwhile you need the e-zinc. It's very important. Without the e-zinc, this regulator gets hot easily, easy. So you need the e-zinc, and there's no variable resistor on the board. Now one more thing again is this crystal is 6.144, not 6. 6 is still going to work, but your output frequency is going to be around 48 amps. So it's better you use 6.144 for it to have like 50 amps. So that's all for that. So that was good. That was good. So for me now, I'm using a 12 volt input adapter. This is right here. So I'm using the 12 volt adapter to power this board, just to confirm before placing the IC. The IC, I don't know, it's very expensive. So one thing you have to do, you use your multimeter to check probably the voltage around the IC, that's your microcontroller, is not above 5 volts. All microcontrollers, not Usher, some use 3.3 volts, but most use 5 volts. So now this is my 7805, and the back of my 7805 should give me a negative, so I'm using it as my negative source to test. So one thing you have to notice is you just be looking at the multimeter on the board. So your pin 1 on the board without the IC connected to it should give you 5 volts. That's 4.9. That's the master clear. Now pin 28 should give you 5 or 2. So and this give you 2.5 volts. The next two should give you 2.5 volts. The next two 2.5 volts. This is your battery input. That's 1.33. So that because using I'm designing this board for a 24 volt inverter, so I'm using 100k. So the relay too, as you can see, this 24 volt coil relay. So and this crystal alongside with my 22 picofarad. It doesn't mean you can't use what's it called? You can use doesn't mean you can use the 3 picofarad, but you can use it. It's still gonna work. So back to what I'm saying. Yeah, back to what I'm saying. For a DSP IC, so pin 28 and pin 27 are both the positive and negative. So pin 27 is the negative, pin 28 is the positive. So that's why I'm having a voltage size out. That's I'm having 5 volts at this junction. I'm having 5 volts at this junction. So if that's the case, I guess everything is working fine. So now one more thing you have to test. You have to test the 8-pin sockets. That's the one for your dsp30f2010. So pin A should give you 30 volts. I'm having 10 volts, but when you're using a 24 volt battery, it should give you 30.6 volts. But since I'm using a 12 volts, the regulator already removes some voltage based on the internal diode and internal resistance of the regulator. So I should have a 10 volts, 10.8 volt, because I'm using a 12 volt adapter to just test the board. So the voltage at this junction, that's me measuring the 2 A zinc of the regulators, should give me 10.8, whatever the voltage give you. But normally it should be 13.6 on 24 volts, another voltage. So that's it. Now I guess all is been set. So after this has been done, before you remove the power supply, before you feed in your TLP, for you to check for a 40 or a good TLP, you need to attach. And one more thing I have to point is this: if you check the board very well, you see A1 and A positive, A negative, B positive, and B negative. Now the simplest meaning, or the simple meaning of this is that the A positive means your high side 1, A negative means your low side 1, your B positive means your high side 2, and B negative your low side 2. So my high side 1, that's my A positive, and my high side 2, my B positive, actually has a floating voltage at the pin 5. So as you're having, what I'm going to do is this: I need to loop my pin 5 to the negative of the board, just to test it on the TLP. Probably can be working very well. So one thing you're going to do is this: you join this to this, you join this to this. If you check the two low side, you see that the pin 5 is connected to the ground, just for testing sake. Once you're done with the testing, please desolder this junction from this junction. But just for testing sake, join this to this and this to this, just to test the TLP. Maybe they're working very well. So
No.
So first thing you'll do is this: this is a keypad for programming of the IC, for it to configure the 12 volts, your 24 volts, your 96 volts, or whatever voltage you just design. You are designing 6 volts, that one is just left to you. So now we check the keypad. You see that this is pin 1 and pin 4. I mean number 1 and number 4. So same thing on the board. connect your number 1 to number 1, the number 4 to number 4. So I'm just going to connect directly, just like this. So after done that, what you're going to do is just keep your keypad to one side, and your microcontroller, connect it directly to the board. So after done that, you can now power the board. So connect your voltage source again to the board just for testing. I guess it's working. Now you can see, without pressing the keypad, it's just giving the normal voltage, AC input, charger off, and blah 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 blah. So one thing you're gonna do is this: before connecting the positive of the board, hold down your enter button. So your enter button should be pressed down before connecting the power source. So I'll hold the enter button. Now it's asking me enter setup. N means no, Y means yes. So press enter. So version 4.3, and this calibration. That's number 1 is calibration, number 2 is no load test, number 3 is option, number 4 is parameter, and number 5 is discard, and 6 done. That's if you throw it or you're calibrating. So first thing I'm going to do is this: I'll go under option. It's asking me, am I going to use micro switch? Micro switch actually means your press button. So if you're using a micro switch, set this N to yes. I'm using a micro switch. So asking me, are you using a solar switch? If yes, you set the solar switch to on. That's yes. You're using a solar switch. No, you're not using a solar switch. So if yes, you put yes. If it's no, you put no. Oh, so you have to start again. So you hold down your button, the enter button, and drift to yes. So first thing you'll do is this: half, up, down. I will up, enter, and down. So up means you're going up, you're ascending. So I'm going down to option again, micro switch. I said yes. And the solar switch, I'm not using the solar switch, so I'm going down to the LCD. Now that's giving me LCD line. Now from default, LCD line is 1, meaning that's 1 row. So when you increase this to 2, to change to 2 rows LCD configuration. So from there you go down to exit. After you can go from exit. From exit you return back and return it back to the option. And parameters. Under the parameters, you set your low battery, and you set your low battery cutoff. This is low battery cutoff, and this is low battery beeping. This is where the beeping is going to start from. Probably okay, you want the battery to be beeping from when the battery is getting low. The beeping sound should start from 11 volts. You set this to 11. You just increase using the up button. Okay, I want the beeping sound to start from 11. You press enter. Now I want the battery to cut off. That's your battery too low. Cut off on, let me say, cut off on 10.4. It's good. 10.4 is good. So you save it. Now your battery full. Now your battery full cut off. This is battery full cut off. Now under the battery full cut off is 14.4. That's for 12 volt configuration. Now I'll be back of your mind. Anything you're doing, if you're designing for a 12 volt, follow a 12 volts. For instance, a 12 volt battery should cut off at 14.6 or 14.7, depending on how you want it. So for a 28 volts, you should know that 14.6 will work for it. So it should be like let me see, it should be around maybe 29.2, or I don't know, whatever what you use, but it must be times 2 of it. There shouldn't be a mistake in this region. So for a 12 volt design I'm designing now, a 14.4 volt is still enough for the battery to cut off. So but I'm going to increase this to 14.6. And my absorb mode means there's a bulk charge and a floating charge. A floating charge. Okay, there's a absorb charging and a bulk charging. So the inverter board is going to charge the battery up to 13.8 with the full charging amps, and start reducing the charging amps gradually until the battery gets full. So your absorb charging is going to resume after the 13.8. So that's just that for that. So one more thing you need again is this your inverter output voltage. So if you want the 220, or you want a 250, or you want a 230, any voltage you just want at the output of the inverter, just set it this point. So I'm setting on to 225, and that's the enter button. So from there again I move down to inverter load. This actually means the maximum load the inverter is going to handle. So I'll set this up to 750 watts. And that's good. And the charging amperage. Now from default, the charging amperage is 4. So you can increase it down to, let me say, 8 amps. And use the factory resets. Maybe you want to reset all what you set on the parameters setup. So maybe you've made a mistake, you want to reset it. You have a yes. When you enter here, you have a yes and or a no, option. So I'm not resetting it. I'm going through exits and I'm out of the parameters. So I'm moving down to done. Done actually means you're saving the old parameters on the memory of the chip. It's actually the EEPROM memory of the chip. So setting components, and that's done. So the old stuff is being saved now, and I still need to calibrate my battery voltage to be the same with the one displayed on the screen. So first thing I'm gonna do is this. I'll press my enter button. I'll take it to yes. So under calibration, you have battery voltage. You can calibrate your battery voltage, calibrate your output voltage, calibrate your inverter load, calibrate your AC input, calibrate your charging amps, and exit. So first thing I'm going to calibrate is my battery voltage. So now what the board says is 21.8, and I'm sure it's not 21.8. So first thing I'm going to do is this. I'll use my meter to check the voltage on the board. That's the voltage entry into the board. So you can check that from, you connect your negative probe to the zinc of the, or just this negative side of the board. There's a negative on the board. So connecting your negative probe to the negative part of the board and your positive probe to the input of the battery. So I'm having a voltage of, let me see, I'm having a voltage of 11.5 volts flowing through the board. So, and this guy is telling me right here is 21.8. So what I'm going to do now, I'm going to reduce this 21.8 volt to 11.5 volts. So what I'm going to do is this. I need to just press the down button to reduce. I'm just going to take some time, but to reduce gradually. So you hold down the down button and you set it down to 11.5 to be the same with the one on your multimeter. I don't pass on. Yeah, that's good. So I'll need to save it. That's an half of memory. So I need to hold this again and redo it. I made a mistake here. So under my calibration, I'll set my battery to 11.5. I'm sorry, I need to check again the battery voltage to confirm it's still at 11.5. So this is 11.8 on my multimeter, so I need to set the battery to 11.8. So and that's good. So I'll just need to go down to done to save it. Now we cannot check, probably both of them is okay now. This this 12.1 and this 12 on the multimeter, as you can see. This 12.1 and 12 on my multimeter and 11.9 on the LCD, so it's pretty good. So what we're gonna do again is this. For me to check now, probably the TLP side is working very well. First thing I'm gonna do is this. I'll hold down the enter button again, go through the loop again, hold down the enter button. So we test for the TLP, probably TLP. So how are you gonna test when the TLP is working? Now first thing you're gonna do is this. To test when the TLP is working, you check your screen, this calibration. On this calibration, you enter, you go to AC output. Now under the AC output, you press. Normally if I'm using a 24 volts supply this board, since I'm using a 12 volts if I'm using the 24 volts supply, the relay should click, but I'm using the 12 volts to just power the board. So now once I entered the AC outputs of the board, as you can see, I should be having signal at the pin 2 of each TLP. I'm having 2.38 without connecting the TLP to it. So having done that, I need to fix in my TLP one by one and check the signal at the other side of the autocoupler. So one thing I'm going to do, I'm out to disengage the signal coming out from the TLP. So I'll disengage it and feed in my TLP. This is the 4 TLP I'm going to be using. So before clicking, I'll just need to fix TLP. So I fix in the first one. It doesn't have any sequence for you to fix it. You can fix it anyhow. So it's not like you fix the first one first before. No, I can fix it anyhow. I can decide to fix the third one or probably the next one. I don't know. Anyone you just feel like fixing, just fix it. Fixing is fixing. Yeah. So I'm fixing the TLP. The last one. Yeah, I guess we're done. So what we're gonna do is this. For me to check the signal on the other side of the TLP probably is working very well. We press the enter button. So once this enter button is being pressed, there's already now the signal that is being sent from the microcontroller is going to reach the other side of the autocoupler. So what you're going to do is this. The first thing, you put your negative probe to your negative side of the board, and you need to watch your LCD around your multimeter squarely. So this is my low side, as I said, low side of my negative low side of my B side. So the low side 2 is giving me 4.0607. so the low side 1, 2, that's a negative, should give me the same voltage. So I'm having 4.14, which is not too close. So the voltage must be close enough for it to work. The voltage must be the same. Let me say the same. The voltage must be the same unless you have. If you use the MOSFET board like this, the main board like this, what's going to happen is this: like you have a blasting of MOSFET. So what you're going to do is this: you need to change the TLP. You swap them to each other to check the one that's going to correspond. But I have to make sure the low side right here is the same thing with the next low side. So it's a pretty different between the two of them. So what you're going to do is disengage again, and you need to swap. Let me swap this one to the other side. So let's test. This 14.2, and this one's still giving me. So probably is the one. This one is somehow, I don't know, different property with different TRP. So probably they're not from the same manufacturer, although they are very different in properties. So what you just need to do is this. That's good. So I keep checking until this is 14.4 and this one too is 14.4. So now we're having close value for both of them. The first one is giving me 14.4, 14.14, and second one is giving me 14.14. So the two low sides are okay. Now probably just use the marker to just identify that okay, this is negative and this is the second negative side, that's low side. So now I need to test for the I side. Now on the I side, one, that's the A positive, is giving me 3.848584. It's switching, that's where it's not really stable. So and 3 points, this one's giving 3.84 and then giving me 3.76. Well, what you need to just do is this. Let me measure from the transistor end. So for you to measure for the transistor end, what you need to measure is this. You need to measure the emitter of your transistor, and you check the configuration. Now the configuration of these two IC as these two transistor is this. Now this is your E, this is your C, and this is your B. Now it's emitter, collector, and your base. So this is your 640 or your 639 transistor. So the emitter is the output. Your emitter is the one feeding the connector at this region. So all you just need to do is this. I need to measure my emitter, probably the voltage and the emitter. So the first one is giving me 3 points. Now let me measure the emitter of the low side first. So the emitter of the two low side, the first one is giving me 14.12, and the other one is giving me comment. The other one is giving me 14.13. So two of them is okay. Now this one now right here is giving me, that's for the high side. The other side is giving me 3.83. So the second high side so is giving me, the other side is giving me 3.83 and 3.83. So the two sides are okay, I guess so. So the all TLP are okay. What you need to have in the back of your mind is this. This first TLP and the third TLP should give you the same voltage, and this one too, the second and the fourth should give you the same voltage. Now having in the back of your mind that there's a loop at the back just for testing. So once I disconnect this guy now, I need to remove this jumper from the back unless you're blasting your MOSFET. So don't forget. So